In this video, we're going to be talking about ion-dipole interactions. Ion-dipole interactions are a form of intermolecular force. But before we talk about ion-dipole interactions, let's review. What are intermolecular forces? They are forces of attraction and repulsion between neighboring molecules. Simply put, they are forces between molecules. They were discovered by a Dutch man named Johannes van der Waals in 1873 to explain the properties of real gases. Various types of intermolecular forces include London dispersion forces, dipole-dipole forces, hydrogen bonds, which are a stronger type of dipole-dipole force, and, of course, ion-dipole interactions. The two parts of ion-dipole interactions are ions and dipoles. Ions are atoms or molecules that have a net electric charge due to a loss or gain of electrons. Examples of ions include positive sodium ions, negative chloride ions, positive lithium ions, and negative fluoride ions. A molecule that has positive and negatively charged regions are dipoles. This occurs because one atom is more electronegative than others. Examples include H2O, or water, that has a negative dipole around the oxygen area and a positive around the hydrogen area, or NH3, or ammonia, that has a negative dipole around the nitrogen area and a positive dipole around the hydrogen area. Dipole moment is measures the polarity of a chemical bond within a molecule. The net dipole moment is the sum of all moments in a molecule. They are formed when there is a difference in positive and negative charges in different areas of a molecule. They are typically represented as an arrow that points in the direction of the dipole, like the arrow seen here. Okay, now what are ion-dipole interactions? They are electrostatic interactions between a charged ion and a molecule that has a dipole. When ion-dipole interactions form, the molecules orient themselves so that the positive and negative charges are next to each other. They typically form with an ionic salt and a polar liquid. Here we see the negative anion interacting with the positive dipole of the polar molecule. Below that, we see the positive cation interacting with the negative dipole of the polar molecule. Examples of ion-dipole interactions include NaCl, or sodium chloride, which is the ion that is dissolved in water, which is the polar liquid. In this picture, we see the positive sodium ion interacting with the negative dipoles around the oxygen in the water molecule. In this picture, we see the negative chloride ion interacting with the positive dipole around the hydrogens in the water molecule. Other examples of ion-dipole interactions include sodium iodide dissolved in water and lithium chloride dissolved in water. Ion-dipole forces are typically stronger than London dispersion forces, dipole-dipole forces, and hydrogen bonds. This is because the charge of the ion is greater than most dipole moments found in polar bonds. Ion-dipole forces are extremely strong and are the reason for aqueous solutions being able to form. The strength of the ion-dipole force is proportionate to the charge of the ion. Let's review. Ion-dipole interactions are a type of intermolecular force, which is a force between molecules. Ion-dipole forces are interactions between an ion and a molecule that has a dipole. Popular examples of ion-dipole forces include sodium chloride dissolved in water, and ion-dipole forces are the strongest intermolecular force because the charge of the ion is stronger than most dipoles. Thank you.